Okay, so moving on to the next one. It says the velocity function v in meters per second of the particle moving along the line is shown in the figure. Okay, so we have this figure here. So find the particle's change in displacement and the total distance traveled on the interval from 0 to 16. Okay? Well, remember, total distance is the absolute value of velocity on a particular interval. Okay? So we already know that we're going to have the integral from 0 to 16 of the absolute value of our velocity function. Okay? So we already know that much. Now this function is not just like a quadratic or absolute value. It looks like it's a piecewise function. Okay? But honestly, we're not really too concerned about that because we're going to be taking the antiderivative of velocity. Antiderivative is nothing but the area underneath the curve. So even if we don't have an equation, we can still figure out the integral of this function because we know we got to look for the area underneath the curve. So we basically have a triangle, we have another triangle, and then we have a small little trapezoid here. So we can basically have to find the areas of all of those evaluated on the respective intervals. Okay? And the thing is, we got to be careful here because we're looking for total distance. We're looking for displacement and distance. Okay. So if we're looking for total distance, remember it's absolute value, so it's always going to be positive. Displacement, okay? Displacement's a little bit different. Okay? As said before, displacement tells us the distance and the direction, okay? So we got to make sure that when we're finding the change in displacement, it doesn't matter whether the areas are positive or negative, whatever they are, that's just exactly what they're going to be, and that's going to give us our change in displacement. So let's go ahead and let's find our areas here. I'm going to label this area 1, I'm going to label this one area 2, and I'm going to label this one area 3. So then that way, when you guys are looking at this, you'll know exactly which area I'm talking about. So for the first one, it's a triangle. Well, old school area formula, 1/2 base times height. Okay? And honestly, I'm going to do change in displacement first. I'm going to make my height negative. Because, again, I'm below the x-axis, so my area is going to be negative there. So for that first area, my area is going to be -8. For that second area, it's another triangle, so 1/2 base, that's a total of 1, 2, 3, 4, 5, 6, 7, 8 units. And a height of 4. It's positive because it's above the x-axis, so that's going to be a total of 16. And the last area is the trapezoid. Remember, trapezoid's formula is 1/2 the height times the sum of my two bases. So it's 4 plus 1. So for a total of 5. So the area of region 3 is 5. So to find my displacement, all I do is I just add these areas up together. So that's -8, 16, and 5. Oops. I missed something. This should have been a -5 because it's below the x-axis. So then it's going to turn into a -5. So I'm going to have a total of 3 meters. My displacement is 3 meters. To find my total distance, all I do is add the areas, okay? So my total distance, I'm going to add all my areas, and on top of that, they all have to be positive. So that's going to be a +8, a +16, and a +5 for a total of 29 meters. I've traveled to 29 meters for this particular function. Okay? So it's still involving integrals. Just this time, when we're talking about a total distance, we are talking about basically the area, the absolute value of the area underneath the curve. Okay? Displacement is just regular good old area. Last example that we'll do is that the culture bacteria is starting with an initial population of 100 bacteria. The rate at which the number of bacteria changes over 1 month period can be modeled by that particular function. Okay, this one is definitely going to be a calculator type question. Find the population of bacteria 20 days after the culture was started. Okay, so we have our rate of change, hint, hint, rate of change, think back to derivatives, rate of change equals derivative. So basically that R of t function is our velocity function. Okay? And so then capital R, which basically would be our displacement function, would be what I'm looking for here, okay? Don't forget, capital letter means we're basically going backwards, taking the antiderivative. All right? So 20 days. That is the integral from zero, the very first day, the start day 0, to 20 days of our velocity function, okay? So from 0 to 20 of our velocity function, which was R of t dt, okay? And once I actually take the antiderivative of that, that's going to give me R of 20 minus R of 0. Because remember, once we take the antiderivative, we get R of t, because that's my displacement function. And then I have to evaluate it on the bounds from 0 to 20. So I do 20 minus 0. Okay? Now it does say there was an initial population of 100 bacteria. So whatever answer I get there, I need to add 100 to it because that's going to actually represent how many bacteria I have after 20 days. Okay? So I'm going to go ahead, I'm going to evaluate this into my calculator so I can actually get a number here. All right? Okay, so again, math, antiderivative, I'm going from 0 to 20. My function, it was E, and then 0.273 t, remember I can't put t up to the x, and then dx, I believe that was the problem, yep. And I evaluate that. So the three significant figures, this is going to be 857. That 4 does not have me round up. Even though it's 0.499, three significant figures, that 4 does not have that 7 round up. So 857, that's how much bacteria I have. But then I got to remember I have to add 100 to it. So 857 plus 100 is a total of 957 bacteria. And that's how many bacteria I have after 20 days that the culture was starting. With my initial 100, and then of course after the 20 days. Okay? So hopefully, you know, this is basically just application type problems with antiderivatives integration. I'm going to give you guys a few problems to work on, okay? You guys are going to work on them in class. You finish them up for homework, and then any questions that you guys have, I'll address them tomorrow in class, okay? Hope you guys have a good one.